Hi grade 11s and welcome to this video. In this video we'll be working on Eastern Cape's grade 11 mathematics test, and this is for September 2023. I know it says October, but it's probably a September paper because this paper is only worth 50 marks and the time allocated is 1 hour. Okay, normally if it was a grade 11 November exam, then there would be two papers and each paper would be worth 150 marks and the time allocated would be 3 hours. Okay, so that was probably a misprint. Okay, so that is the paper we're going to be working on, and let's get into this video. Question 1.1 says, given the sequence 10, 7, 4, and 1, write down the next two terms of the sequence. Okay, so do you see how the sequence is moving? We have 10, and then what do we do from 10 to get to 7? Well, we would say minus 3. And then what do you do from 7 to get to 4? You would also say minus 3. And then from 4 to 1, minus 3. So you can see that we are just subtracting by 3 to get the next term. So the next term would be 1 minus 3, which gives us negative 2. And then negative 2 minus 3, which gives us negative 5, and those are the next two terms. Moving on to the next question. Question 1.1.2 says, determine the formula for the nth term of the sequence. Okay, so this just depends on which method you are using. We can see that because we have a constant difference, okay, the difference that we keep subtracting or adding to get to the next term is constant. This is a linear pattern. So you can use this method where you say Tn equals a plus n minus 1 times d. This formula is mostly used in grade 12. If you weren't using that, you could just use this one. Tn equals dn plus c. So d stands for the difference or constant difference, which we can see is negative 3. Okay, if you said 7 minus 10, you get negative 3. So that is what we add to get to the next term. Okay, we add a negative 3 to get to the next term. So that is Tn equals negative 3n plus c. Now how we find this missing c is just by using one piece of info that we have here. Say we look at term 2. Okay, you can see that term 2 has a value of 7. So I'm going to substitute that info here. I'm telling them that term 2 has a value of 7. And so I will say term 2. Now, do you see how in place of n, we have 2 there? So it just means that wherever you see n, replace it with 2. So we have negative 3, and then there's 2 plus c. But here's the thing. We know what term 2 is. The value of term 2 is 7. So this is 7 equals. So when we multiply here, we get negative 6 plus c. Transpose the 6, you have 7 plus 6, which is 13, is equal to c. So finally, we know that Tn equals negative 3n, and then we just put that c there. Okay, so plus 13. And that is the general term, the n term. Moving on to the next question. The next question, 1.1.3 says, which term of the sequence is equal to negative 179? So which term? Term what of the sequence has a value of negative 179? And so in place of this, we're going to substitute n because this is what is unknown. We don't know what term number this value belongs to. And so you can see that from our formula, all we are going to do is substitute in place of Tn, we substitute negative 179. So this is negative 179 equals negative 3n plus 13. Okay, the n is, okay, the coefficient of n is already negative. We might as well transpose it. So we have positive 3n equals, and this is positive 179 plus 13 is 180, and then plus 12 is 192. Okay, so we have 192 over there. And then divide both hand sides of the equation by 3. And finally, n equals, let's just find out what 192 divided by 3 is. It is 64. And that is our answer. And that is it for this question. Moving on to the next question. Question 1.2 says, given the first three terms of a linear pattern, okay, linear sequence, and these are the first three terms. So this is term 1. That is term 2, and this is term 3. They want us to determine the value of x. Okay, grade 11s, This particular question shows up a lot, so make sure you remember how to do this. They can ask it in any term. I've seen this in term 1. I've also seen it in June papers, so you can see that it can show up in any term. Okay, so here's the thing. With a linear sequence, there's something we know about a linear sequence, and we saw this already from the previous question. Did you notice that in the previous question, when we were trying to get to the next term, we just kept saying minus 3, minus 3. Okay, so a linear pattern has a constant difference. And we find that constant difference by saying the next term minus the previous term. Okay, if you said 7 minus 10, you get negative 3. 4 minus 7, you get negative 3. Okay, so that's what we're going to use. Because we know it is constant, we can actually create an equation from this. So we'll say term 2 minus term 1, and so that is x plus 9 minus, and we have 3x minus 2. Now we're using brackets because, of course, we're subtracting by something that has 2 terms. And then we can find this, okay, difference again, which is still going to be the same thing. So we have 2x plus 5 minus, and that is x plus 9. And here's the thing. Because it is a constant difference, this is d, but this is also d, they are exactly the same. And so we are just going to equate them. So we're making them equal because we know they are the same. And so let's go ahead and simplify. This is x plus 9, and then we distribute in negative 3x, and then positive 2 equals, and we have 2x plus 5 minus x minus 9. Just simplify the left and right hand side first. X minus 3x is negative 2x, and then 9 plus 2 is 11. Is equal to, and here we have 2x minus x, which is x. 5 minus 9 is negative 4. Okay, and now we can transpose. So this comes over to become a negative x, so negative 2x minus x is negative 3x is equal to, this is still negative 4 on this side, and then the 11 comes over to become negative, and so we have negative 15, okay, and then divide both hand sides of the equation by negative 3 to solve for x, and finally x is equal to 5, and that is our answer. And that is it for question 1. Question 2 says, given the quadratic pattern, and we have negative 128, negative 84, negative 48, and negative 20, determine the next 2 terms of the pattern. Okay, so to find the next 2 terms, this is a quadratic pattern, so you need to remember that. Unlike a linear pattern, it doesn't just have one constant difference, okay? It has a first difference and then a constant difference. So let's go ahead and find that first difference. We'll say negative 84 minus negative 128. I'm just going to use a calculator for this. Okay, and that first difference value is 44. And then we'll say negative 48 minus negative 84, which becomes a plus 84. And we get 36. And then negative 20 minus, or plus really, 48. And we get a 28. Okay, so that is our first difference. Now we can get the second constant difference. So 36 minus 44, it's going to be negative. So we get negative 8. And then 28 minus 36, also negative 8. Okay, so this is what we have. And now to find the next 2 terms, we are going to use the fact that we know the constant difference is constant. Okay, that's second constant difference. So it will keep being negative 8. So to get this first difference value here, we say 28 minus 8, which is 20. And then to get the fifth term, okay, to get the fifth term, we're going to just say negative 20, and then this is just a positive 20, so negative 20 plus 20 is 0. So the next term is 0, and then term 6, let's find that. Okay, again, constant difference is constant. It stays negative 8. 20 minus 8 is 12, and so we have here 12, and then 0 plus 12, because this is just positive, so you're just adding. So this is positive 12. And so the next 2 terms are 0 and 12, and those are our answers. Moving on to the next question. Question 2.2 says determine Tn, the general term of the pattern, in the form of Tn equals an squared plus bn plus c. Okay, we have everything we need to find this. And all we're going to do is we're going to use the first terms of the quadratic pattern, the first difference, and the second constant difference, and we will equate them to the following. So the second constant difference, that first value gets equated to 2a. So 2a equals -8. And then this gets equated to 3a plus b. And then this is a plus b plus c. So let's go ahead and find the value of a first. So if 2a is equal to -8, then divide both hand sides by 2, and a is equal to -4. And now that we have a, 3a plus b equals 44, but we know what a is. It's -4. Okay, then plus b equals 44. 3 times -4 is -12, and then plus b equals 44. And then you're going to transpose that. So this is 44 plus 12, which gives us 56. And now finally a plus b plus c. So we know that the value of a is -4, and then b is there, and then we'll just say c. So -4 plus 56 plus c equals, and we have -128. Okay, so 56 minus 4 is 52. C equals, we have positive 52 here, but when you transpose it, it becomes -52. So minus 52. And so that is, so 120 plus 50, 170, and then plus 10 is 180. So C equals -180. And so here we are. And so finally, Tn equals -4n squared, and then plus 56n and minus 180. And that is our answer. Moving on to the next question. Question 2.3 says, given that Tn is equal to -4n squared, I'm just checking that, yes. Okay, it is correct. So given that Tn is equal to this, determine the biggest numerical value of Tn. Okay, the biggest numerical value. In other words, the maximum value. Okay. Do you see that in this general terms equation? Do you see how this looks like a quadratic equation? And that's because it is. It is quadratic. So if you had to draw this as a graph, it would create what type of graph? It would specifically create a parabola. So you have a parabola, and do you see that the value of the coefficient of n squared is -4? So this means that this is a sad face parabola, or really a concave down parabola. And we have to find the biggest number that this can ever reach. So you see the results that we have. For example, let's give an example. You see this point over here? It has a term value, okay, or an x value. The x value may be, let's say, something like 2. And let's say the y value was 7. So it means that at term 2, you have a term value of 7. That means term 2 is equal to 7. This is just an example. And all through, you see different term values that you have. Okay, here we have this y value. The y value tells you the term value. The x value tells you the term number that belongs to that value. But throughout, do you notice that because of the way this graph is shaped, this is the point where it will reach its highest y value, its highest term value. Okay, it will never get higher than that. That is the maximum term value that we will have there. And that's what we're trying to find, because this would be the biggest numerical value of Tn. So how can we find this? What exactly is this point? This is also known as the turning point. And we're just trying to find the y value of the turning point. So to find that, we first need to find the x value. And we can find this since it is already in its standard form. We would just have to find that x value of the turning point. You can use this formula. X is equal to -b over 2a. I'll just call it n because, we're finding an n value. It's a term number, and then we'll substitute. Okay, so this is equal to, and we're going to say negative. Now remember, it is in the form of an squared plus bn. We already knew that. Okay, so you can see the value of a, b, and c. So this is negative, and then what is b? It's 56 all over, and we have 2a. A is -4, and let's go ahead and get our answer. So negative and negative will just cancel. We know that 2 times 4 is 8. 56 divided by 8 gives us 7. Okay, so we have 7 over there. And now we can finally take this. Okay, so this is just the n value. This is just the x value really at which we will have that maximum. And now to find the actual maximum, we're going to take that n value and substitute it into the equation of our function so that it can tell us the corresponding y value. Okay, that Tn value. So we'll say the maximum is at term 7. So term 7 equals, and substitute 7 in place of n, 7 all squared plus 56 times 7 minus 180. And let's finally get our answer. And the maximum value, or the biggest value that this Tn pattern ever reaches, is 16. And we can just finally conclude that. Okay, the biggest numerical value of Tn is 16. And that is our answer. Moving on to the next question. Question 2.4 says, given h of n is equal to Tn plus k, okay, so a new graph, h of n equals Tn plus k, for which values of k will Tn not have any positive values? I think they meant will h of n, because it wouldn't make sense for it to be Tn, since Tn is the one that is being manipulated. So for which values of k will this new graph not have any positive values, since the new graph is created by shifting Tn either up or down? Okay, so to think this through, we're just trying to find out for which values of k, okay, this is k, it's a shift that could be up or down because you're adding to the entire Tn. It's not like you're shifting it to the left or the right where you're applying this shift to the n. You're taking Tn, the entire graph, and then you're either shifting it up or down. Okay, so the graph that we had here is going to help a lot. Since we know that this new graph is being shifted, we don't know if it's shifted up or down, we need to determine that. But in the new graph, we must no longer have positive values. Okay, so no longer have any positive values. We can control this from the turning point. You see, we know the turning point is now, it's at 7 and 16. So we can put that down. We know this is 7 and this is 16. If this is 16 over here, the new graph they are referring to should no longer have any positive values. So look at what they mean by this. You see this graph right now? It has multiple positive values. Remember, on the y-axis, this is where we're going to see our values. Okay, and then on the x-axis, that's when we're seeing the term numbers. Okay, for example, term 7 has a value of 16. So all through we have positive term values. Look at this term over here. I don't know what term number it is, but this term has a positive value. See, a positive number on the y-axis. That's where it maps to. And then, for example, this term over here, okay, it has a positive y value, and so on. So if we are applying this plus k to the graph, it's either going to shift it up or down. How should we shift this graph so that it no longer has any positive values? Okay, so how we should shift the graph is, if you shift it up, you see how that does not sort out the problem? See, over there, you have a term with a positive y value. We don't want that. We want all the terms to no longer have positive y values. They didn't say negative, they just said it shouldn't be positive. So it can be 0. So look at what we can do. We can take this graph and shift it down. If you shift it down and you shift it to the point so that that turning point sits on the x-axis, then look at what you have now. At this point over here, that turning point, you have a y value of 0. Okay, so this would be 7 and 0. The x value is 7, the y value is 0, meaning the term number is 7, but the term value is 0. 0 is a value that is not positive. Okay, it's neutral, it's neither positive nor negative. So it can be equal to 0, but it mustn't be positive. Now, do you see that all the terms, all the points below this, they all map to negative term values, okay? Negative term values. So that's what we need to do. We need to shift this graph down to the point that it sits on the x-axis. So how do we do that? Well, since this is 16, okay, this is 16 over here, and we just shifted it down so that that y value now is 0. It means that you need to shift it down by 16 units. So shift it down by 16 units. How do we apply a downward shift? If you want this graph to go down, you need to say minus 16 and then it will move down. So we just need to ensure that this value of k is, it can be negative 16 and then it can be anything below 16. So for example, like minus 17 would be fine because then it's going to shift down an extra unit and then it will always have negative values. It will never have a positive value. So what k should be, k should simply be a value that is either less than or equal to negative 16. Okay, it can be equal to negative 16. There it will have a y value of 0 and then negative y values, or it could be anything lower than negative 16. And that is our answer. Okay, that is our answer for question 2.4, and that is it for question 2. Question 3 says two number patterns, the one consisting of uneven numbers. Honestly, they should have just said odd numbers. And the other consisting of even numbers. Okay, so we know that one pattern has odd numbers and the other one has even numbers. So they are combined to form a new number pattern as shown below. Okay, they were really nice to tell you at least, because normally in grade 12, they don't state these things. They'll just put the pattern down, and then once you see you can't find a constant difference or common ratio, or you can't see that this thing is quadratic, then you would go to think, okay, maybe it's just two patterns that have been combined. So it was really nice of them to actually tell you that these are two patterns that have been combined. So the first question is to write down the next two terms of the pattern. Okay, so you just need to remember that these are two different patterns that have been combined. So we need to find those next two terms separately. Okay, as you can see, this is odd, 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 and then these are the even ones. So even, even, and even. Okay, so find the next two terms of the pattern. So you're just going to view them as two different patterns, and I'm just going to put them down already because we'll probably just need them for, the next questions. So we know that our odd pattern is 1, 5, 9, 13, and then the even one is, okay, let me put that in blue. The even is 2, 6, 18, and 54. And we'll just figure out what they're doing there. Okay, so in the first one, what do we do from 1 to get to 5? We would add 4. What do you do from 5 to get to 9? You would add 4. From 9 to get to 13, 4. So we can see this is a linear pattern and its constant difference is 4. So to get the next term, and you need to now put it in order. You see that because we went odd, even, the next one is odd, and then the one after it is even. Okay, so the next term would be, again, plus 4, 13 plus 4 is 17. So we know this is the next term. And then let's find the next one here. What do you do from 2 to get to 6? You would, I doubt that's the case here. But okay, you would add 4. From 6 to 18, you see, that's 12. And then from 18 to 54. So clearly this is not a linear pattern. Okay, so it's not. I doubt it's quadratic as well, but let's just see. It actually just looks like, so do you see from this term, right? 2 to get to 6, what would you have done other than add 4? Okay, so let's think about multiplying, dividing, things like that. If you multiply 2 by 3, you get 6. Okay, if you took 6 and you multiplied it by 3, you get 18. 18 times 3, you get 54. So do you see what they're doing to get to the next term? They're just multiplying by 3. Okay, so we know now to get to the next term, you would simply say 54 times 3. So this is just multiplying by 3. 54 multiplied by 3. And so that's 150 and 162. So 162. And so when we tell them the next two terms of the pattern, we'll just show them that is 17 and 162. But we know that they are from two separate patterns. And that is our answer. Moving on to the next question. Question 3.2 says, calculate the 31st term of the pattern. So term number 31. Okay, we're just going to have to see which term exactly it is because you can see that the even terms, okay, the terms with even numbers, they actually form a type of pattern that you guys don't actually work with yet. You guys will work more with this in grade 12. So let's just see the 31st term. 31 is an odd number. Because it's an odd number, you see that it's going to... So 31, let's just see how these ones are going. Do you see that with your odd terms, okay, the ones with odd numbers here, this is term 1, term 3, term 5, okay, term 7. Do you see that their term numbers, not just their term values, but their term numbers are also odd? So term 31 would belong to this odd pattern. We can definitely find that since this is a linear pattern. Okay, so since it's term number 31, we know that it's one of these ones, okay, the reds. Okay, so let's look at this. This is term 1 in the odd, and then this is term 2, and it belongs to the even. And then this will be term 4, and so on. So I'm just trying to see which ones are next to this. So the pattern starts with odd, then even, odd, then even. Then if this is odd, then the next one is even. Term number 32 is even. Now we can look at them as groups. You see term 1 and term 2, they form term 1 of these patterns, okay? They're term 1 in the odd patterns and term 1 in the even patterns. Then term 3 and term 4, they form term 2 in the odd and the even pattern. Term 5 and term 6, that is term 3. And here's why I'm doing this. Do you see that, for example, here, right? This is term number 6, and let me just put that in blue. If this is term number 6 and it is 18, do you see how in the even pattern, term number 6 is actually the third term in that even pattern? So I'm trying to find out term number 31. What term number is it in the odd pattern? Because it can't be term number 31, okay? It's a combination of all the terms added together. Since they have presented all the terms and they've just combined them. So I know it's term number 31 in the combined set, but I want to find out term number what is it in this odd pattern if we only look at the odd pattern alone so that we can actually find that. So with these groups being created, you will notice that this even number, it's always going to tell you, if you just say term 2, right, and you say divided by 2, you find out that this term 2 that we're looking at, it's actually the first term in your even numbers. Likewise, you see how this is term 4? It's actually the second term in the even numbers, okay, because these are both the second terms of their respective patterns. So I'm trying to find out which term are these in their respective patterns. Since this ends with term 32, you see that all we have to do is divide that term number by 2. Okay, term 4 divided by 2 is term 2. This is actually term 2 in this even pattern. For example, here as well, term 2 divided by 2 is 1. This is actually term 1 in the even pattern. So 32 divided by 2 is 16. That means this is the 16th term. Okay, term 31 and term 32 are both the 16th term in their respective patterns. That actually belongs to term 16. That term 31 they were referring to. Okay, so it belongs to term 16 in the odd patterns. So that's all we're trying to find out. What exactly is term 16 in the odd pattern? Okay, to do that, because we're not going to just keep adding 4 the whole time, what we can do is just find the formula of this pattern. So the odd terms are 1, 5, 9, and we can see the constant difference is 4. So it is a linear pattern, meaning to find it, we'll just say Tn equals dn plus c. And so d, as we can see, is 4. So this is 4n plus c. Then just substitute one value into it so that you can find what c is. We can use term 2 here. Term 2 has a value of 5. So we'll just say T2 equals, and in place of n, we substitute 2. So 2 plus c, but we know that term 2 has a value of 5, like we saw. So in place of term 2, we say 5 is equal to, and then 4 times 2 is 8, and then plus c. 5 minus 8 is negative 3, so we can see c is actually equal to negative 3. Okay, so our pattern's formula is Tn equals 4n minus 3. And all we are trying to find is term number 16. Term number 16 in the odd pattern is term number 31 in the overall pattern, okay, in the combined pattern. So term 16 is equal to 4 times 16 minus 3, and then let's just go ahead and find this. And this is equal to 61. Okay, so that's what they were asking for. Term number 31 in the overall pattern is actually 61. Okay, so something you can do to just differentiate this is, can you just call this Pn? I'll just call it P2, just so that it doesn't confuse. And I am actually answering their question where they said the 31st term. So if I call these ones P, right, then I can finally say that term number 31 in the combined pattern, the pattern that they initially gave us, so this, okay, term number 31 is equal to 61, and that is our answer. And that is it for question 3. Question 4 says a pyramid with a square base with a side length of 16 centimeters is sketched below. Okay, so this pyramid has a base that is a square, and the square has the side lengths of 16. So this is 16, and then that is 16 and 16 and so on. And then they tell us that P lies on the square base directly below A. So we can see that this is the perpendicular height of this pyramid, okay, all the way from the highest point to the ground. And the volume of the pyramid is 640 centimeters cubed. That is a very important piece of information. They gave us the volume. So we're going to have to use volume if we were asked to find a specific thing. So they've also given you the formula of the volume. This formula says a third, okay, 1/3 multiplied by A times H. So what they mean by A is, remember how to find the volume of a shape, okay, a 3D shape. You're trying to find how much space can be filled up in this shape. So we'd say the area of the base multiplied by the height. But of course, in this case, we can't just say area of the base times height because the base is a square. Okay, if you set the area of the base times the height, that's finding the area of a rectangular prism. Okay, so it's not that big. So because of that, what we are saying is area of the base times the height, but then you say times 1/3, and then that would actually make up the volume of a pyramid. So that A actually just stands for that area of the base. Okay, so that. And 4.1 says, show that the perpendicular height of the pyramid AP is 7.5 centimeters. So we need to find the height. Okay, what have they given you? They gave you the volume. Okay, they gave you the volume, and this is actually enough to find that height. Look at the formula to find the volume. The volume of a pyramid, we can see, is equal to 1/3 multiplied by the area of the base, and the base is a square. So it is going to be the side times the side, okay? 16 by 16, and then multiply by the height. So I might as well just put it here already. 16 times 16, that will be the area of the base, and then times the height. And we don't know the height, which we're just trying to find, so AP. Now here's the thing. They already gave us the volume of this pyramid. They told us that it is 640 centimeters cubed. So in place of volume, we substitute 640 is equal to, and you see that all we have to solve for here is AP. Okay, 16 times 16 and then times a third. Okay, as a fraction, that is 256/3, and then we have AP, so I'll just say 256/3 AP. Okay, it just gets multiplied. And now to finally solve for AP, the height, you'd get rid of this. You can divide both hand sides by this, or you can multiply both hand sides by its reciprocal. So we'll say 3/256. That way the 3 cancels with the denominator, the 256 cancels with the numerator, and then that's gone. So do the same on this side. Okay, so there we will have AP is finally equal to, because everything cancels here, and then find out what this multiplied by 640 is. So all of that, and as you can see, that is indeed 7.5. So AP is finally equal to 7.5 centimeters. And that is our answer. Moving on to the next question. Question 4.2 says, hence determine the total surface area of the pyramid. Okay, so the total surface area. So we need to find the area of all the faces and then add them together. So with total surface area, you can imagine that you are painting the shape. If you were painting the shape, look at all the parts we need to paint. We would need to paint that bottom, okay? That is the base, which is a square, and we can see that it's 16 by 16. Okay, so to find that base, that is fine. But now with these triangles, how do we find the areas? So it would seem like we have the height of the triangle, but no, we can't really take AP as the height of this triangle, because remember, this is a 3D shape. You have that base, okay, that square, and then you have this height from A all the way to P. That is not the same height of this triangle, unfortunately. The height of this triangle is actually skew. It's like this. It's a slanted height. This is the height of the triangle. This is from the highest point of the triangle to this base. This is the height of the pyramid, but this part is the height of the triangle. So we need to find that. And it seems like they have made some constructions here to actually assist us with finding that. Do you see that AT, that is the slanted height we are trying to find. We need to find AT, and to find AT, we can just use this right angle triangle that has been created here. You see how we have this triangle, we have AP, and look at PT. We actually have PT, because the thing is, this is drawn from the highest point of the triangle and then down to here. That means that this is the center, okay? This is right at the center of the square. Since we know that this shape is a square, we know this is the center. So it means that PT, okay, if this is 16 centimeters, then PT is exactly 8 centimeters. So we've got 8 centimeters here. We have 7.5 centimeters on this perpendicular height. And so we can find this hypotenuse of AT, which is the slanted height. And we need those to actually find the areas of those triangles, okay, the 4 triangles that we have here. Because this pyramid has a square base, you can see that you have one face of a triangle here. That's the first triangle we have. The second one is on this side. That's the second one. And then the third one is at the back over there. And then the fourth one is this one over here. Okay. And all we needed with those are their heights, and we can see their base is just 16. So this is the base of the triangle, and that is the slanted height. Okay, so let's go ahead and find those. So we'll start with the slanted height, that is AT, and let's find that. We have our triangle, I'll just draw it down here. Okay, so to find AT, that slanted height, we'll say AT squared using Pythagoras is equal to, and we would say 7.5 all squared plus 8 all squared. And AT squared equals, and let's just get that first, and that is 120.25. Then to find AT, we square root both hand sides. You don't have to consider any negatives because we're working with lengths. So finally, the square root of this answer is, this is 10.96. I don't think I should round off yet because we're not done. So I'll just leave it like this. Square root 481 all over 2. Okay, that is the height. That is the slanted height. That is AT. And now we can finally find this. So let's just keep track of everything we're finding. The area of the base, which is a square. And then we need the area of each triangle. And we can see that there are 4 triangles here. So first in front, and then the sides, and then the back. Okay, so to find the area of those triangles, remember we can use half base times height. So we're saying a half multiplied by the base of each triangle. Okay, remember we are referring to this triangle, and it's repeated on the sides and at the back as well. So a half multiplied by its base, which is 16, and then multiplied by its slanted height, which is from the highest point of that triangle and then down to the center. Okay, so that was 80. Okay, 80. And then that just repeats 4 times. So first, so front, the sides, and the back. Okay, so to find the total surface area, this is equal to, we just get the area of the square. Okay, so area of the base, which is the square, and then add it to the area of the triangles. Okay, so the area of the square was very simple. That was just 16 times 16. And then the area of the triangles, we know that there are 4 triangles here. And then each of them, we find them by saying a half times their base, which was 16, times their perpendicular height, which was the square root of 481 all over 2. And all you have to do is substitute this, put this in your calculator, and you will get your answer. So finally, the answer is 606, so 606.91, rounded off to 2 decimal places. And remember that its area, so this is centimeters squared, and that is our answer. And that is it for question 4. Question 5 says a spherical glass ball is tightly packed in a box. The box is in the shape of a cube, as shown in the picture on the left. The radius of the ball is 6 centimeters. Okay, from the center to the circumference is 6 centimeters. The diagram on the right shows the cross section of the ball placed in the box. Okay, so the main diagram is this. This is just, you can see it as like a top view or even a side view if you were looking at it as if it was a flat shape. But this is a 3D figure that we have. So they say what volume of the box remains after the glass ball is placed in it. Okay, so to find the volume that will remain once we place this inside, you're going to have to think about what exactly is the volume of this cube. And if we find the volume of the cube, the space filled up in the entire cube, and then we find the volume of the sphere, and we subtract that from the volume of the cube, you would find out the extra space that is left. Okay, and that's what we're going to do. So you see that with that, we're focusing on two things. We need to find the volume of the cube, and then we need to find the volume of the sphere. Okay, so find the volume of the sphere. Okay, so to find the volume of a cube, very simple. It's just the area of that base and then multiplied by the height so that you can get the entire space that is filled up in the shape. Okay, area of the base multiplied by the height, then it will tell you everything, okay, the amount of space that can be filled up in that shape. So that is just because the volume of the base, since this is a cube, all the sides are exactly the same. So we can look at this as side, and this is also side. So it's just going to be side cubed. But then the volume of a sphere, okay, so we need to find out what that is. Remember that you need to remember your formulas. The volume of a sphere is 4/3 pi r cubed. Okay, so there we go. So to find the space that will remain, okay, so volume that remains, I'll call this volume that remains. All we would do is say, take the entire volume of the cube and then say subtract by the volume of the sphere. Okay, so this is it's a very simple one. All you had to remember was this. Okay, so volume of the cube is, how do we figure out what exactly these side lengths are? Well, you can see this from the flat view of it. You see that the radius is 6 centimeters. From the center to the circumference is 6 centimeters, right? So what does that tell you about this square? It means that half the square, okay, that length is 6 centimeters. And so the other half is 6 centimeters. And it means the entire length is 12 centimeters. Okay, so we know that. This is 12 centimeters. We'll put that down. So volume of the cube, it's 12 all cubed. We'll say 12 to the power of 3 minus, and then the volume of the sphere. Okay, so that's 4/3 pi, and we need the radius, which we know. The radius is simply 6 centimeters. Okay, so the radius is 6, and that's all we need to find, and then raised to the power of 3, of course. Okay, before putting it in, let's just find it separately so that we are actually finding what they want us to find. You know that they're going to focus on you telling them what exactly the volume of the cube is and the volume of the sphere. So let's find that separately. If we say 12 to the power of 3, that gives us 1,728 centimeters cubed, of course. And then let's find this separately. Okay, so I'll just write that in terms of pi. So that's 288 pi. And then finally, if we subtract them. So in front of that, I'll just say 1,728 minus this is, okay, there we go. It was just multiplying. I don't know why. And our final answer is 823.22. And this is volume. So it is in centimeters cubed. So centimeters cubed, because they already told us, these are in centimeters. So that is our answer. And that is it for question 5. Question 6 says, a cylindrical aerosol can has a lid in the shape of a hemisphere that fits exactly on the top of the can. The height of the can is 16 centimeters and the base of the can is 2.9 centimeters. I have seen this exact question. It's literally a copy and paste. this is a case of where they are recycling questions. So just make sure that you take note of the formulas they've given you. They've given you the volume of a sphere, which is simple. Okay, the volume of the sphere is 4 over 3 pi r cubed. But you see that we are working with a hemisphere here. Okay, that lid is a hemisphere. And then they also give us the surface area of a sphere. Okay, they're not really giving us of a cylinder, so we're just going to have to keep that in mind. Okay, so 6.1 says, calculate the surface area of the can with the lid in place as shown in figure 1. Okay, so the surface area of this entire can. So when you are thinking about surface area, just think about if you had to paint the shape, how would you find the area needed to paint the shape? Okay, so if we were painting the shape, we would need to paint the lid separately because this is a separate shape. This is a hemisphere, and then we would need to paint the body, which is the can. Okay, so to find the total surface area of this, we would first work with that hemisphere. We have the surface area of a sphere. So of a hemisphere would be half of this because this is half a sphere. Okay, so to find the surface area, we could just say this is equal to, let's just go ahead and get the area of the hemisphere first. Okay, so get the area of the hemisphere, and then you're going to add this to the area of this cylinder. Okay, so this is equal to the area of the hemisphere. We can see they gave us the area of a sphere is 4 pi r squared. So the hemisphere would be half of this. You can just divide it by 2. So you get 2 pi r squared. Okay, so area of hemisphere is 2 pi r squared. Let's figure out this area of the cylinder and what it's going to look like. To find the area of this cylinder, just think about what it looks like. We can see that they've given us a radius of the cylinder, right? And it's also the radius of the hemisphere. And this is 2.9. So you see this creates a circle. The base, okay, we have a circle. So from the center to the circumference is 2.9 centimeters. If you have to find the area of the shape, you would have to cut it and then lay it down flat. If you lay this shape down flat, and let me actually just do it up here so it makes sense. So if you lay this shape down flat, what you have over here is the height still, that is still 16. Okay, so it's just like opening it up like that. And then you have this part, but you see this part, the top was curved to create that circle. So that is a circumference. Okay, that is the circumference. And to find the circumference of a circle, we say pi times diameter. But you know that the diameter of a circle is made up of 2 of the radius added together. Okay, 2 radii. So in place of d, you can just say 2r. So it means just to find the circumference, you'd simply just say 2 pi r, and that would find it. We already know what the radius of that circle is. It's also the radius of the hemisphere. Okay, so you see that to find the area of the shape, just say this side multiplied by this side. That would give you the area of the entire shape. So that's how we would find that. We would say 2 pi r times the height. Okay, so multiply by the height. And then that would be the area of the cylinder. But then there's something else we need to consider because that only covers the body. Okay, so this part, that's all it covers. But to find the surface area of this entire shape, we also have to consider the bottom. Okay, the bottom is a circle. How do you find the area of a circle, that flat shape there? You find the area of a circle by saying pi times radius squared. Okay, so that's what we need to add to this. We are putting the area of the body and then also that bottom circle, which is pi r squared. Okay, so all of this covers the area of the cylinder. We're done with that. And we already have the area of the hemisphere. And all we have to do is simplify this. So with this, we can just start by simplifying. Do you see how 2 pi r squared and pi r squared are like terms? When you add them together, it's like 2 pi r squared plus 1 pi r squared gives you 3 pi r squared. And then plus 2 pi r times h. And all you have to do is substitute. So we're saying 3 pi, and in place of r, we know the radius is 2.9. So this is 2.9 all squared plus 2 pi, and then 2.9, and then multiply by the height, which is 16. And this would give us our answer. So let's go ahead and substitute. And our final answer is 370.80. Okay, so, and the unit of measurement they used was centimeters. So it is area still. So area is always in squared. So that is centimeters squared. And that is our answer. Moving on to the next question. Question 6.2 says, if the lid is 80% filled, the lid, okay, so if the lid, and it's literally exactly like that exam paper. So this was just a copy and paste. If the lid is 80% filled with a liquid as shown in figure 2, calculate the volume of the liquid in the lid. So it's just 80% filled. So looking at this lid. So to find this, do you see that because it refers to the hemisphere and the hemisphere is a 3D shape, we just need to find out what exactly is the volume of this 3D shape and then find out what 80% of this is because it's 80% filled. Okay, so they already gave us the volume of a sphere. So a hemisphere would be half of this. The volume of a sphere is 4 over 3 pi r cubed. Then a hemisphere is half of this. You can either decide to divide this by 2 or just multiply it by 1 over 2. Okay, and that would be the volume of a hemisphere. Okay, so this is 4 times 1 is 4, 3 times 2 is 6, and so that is just going to be 2 over 3. So we have 2 over 3 pi r cubed. Let's find the volume of that hemisphere first. So this is 2 over 3 pi, and then we know the radius is 2.9, okay, then all cubed. And we'd get this first. Okay, so I shouldn't round off in this situation since we still have to find out what 80% of this is. So I'll just leave it as 51.0802 and I'll just leave it like that. And this is in centimeters cubed because it is volume. And then finally to find 80% of this, that would be the 80% that it is filled up to. So 80% of this would be is equal to, and we would just say this amount multiplied by 80 over 100. Okay, so times 80 over 100. And you can just do that. You can do that straight here. So times 80 over 100, or you could just say 0.8. And our final answer is 40.86. And this is still in centimeters cubed because it is still volume. And that is our answer. And that is it for question 6. Okay, so that is the last question for this paper. I hope you guys enjoyed it, and I hope to see you in the future videos.